Good morning, students. So now we are going to calculate electric potential due to a point charge. So consider a point charge Q, and because of this point charge we are going to calculate the electric potential. तो इसको कैलकुलेट करने के लिए हमने कुछ पॉइंट कंसीडर्स किए हैं. से पॉइंट ए विच इज एट डिस्टेंस x away from point charge Q, and we have considered another point P which is at r distance away from that point charge Q. Now we have to calculate the electric potential due to this charge Q. So if we have to calculate the electric potential, so according to the definition of electric potential, we have to bring a unit positive charge near to this charge, and the amount of work done is known as electric potential. So we are going to bring a unit test charge from infinite. Okay. So infinite, when we will bring a unit test charge, so we cannot consider it directly. So that is why we are going to calculate the electric potential or the work done to bring that unit test charge from A to B. And when we will calculate this, we will do integration of that work done. Okay. Now firstly let us calculate the amount of force from location A and Q. So suppose that test charge is at location A, that test charge Q naught is at location A. तो बताइए कितना जो दोनों के बीच में जो फोर्स होगा, that will be equal to, by Coulomb's law we can calculate that force. So F is equal to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So Q naught upon, what is the distance? Distance is x upon x square. Now the small work done to bring test charge Q naught from A to B. देखिए जब आप टेस्ट चार्ज को A से B तक लेकर आएंगे तो आपको कितना वर्क डन करना होगा. सो वर्क डन इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट. सो dW इज इक्वल टू, बिकॉज़ देखिए हम जो इसको डिस्टेंस मूव करा रहे हैं बहुत ही स्मॉल है. A to B, पॉइंट A एंड B आर वेरी क्लोज. सो डिस्टेंस इज स्मॉल, वी हैव रिटन dx. सो वर्क डन आल्सो विल बी वेरी स्मॉल, सो वी आर राइटिंग इट dW. सो dW इज इक्वल टू F into dx into cos 180. Why cos 180? Because we are bringing it here. So the angle form is 180 and cos 180 is minus 1. So dW is equal to minus f dx. Because of cos 180 minus 1, you will get dW is equal to minus f dx. So we have calculated the work done to bring this charge from A to B. Now what will be the total work done? For calculating the total work done, we should do integration of dW. So what will be the limit of integration? So this is known as limit integral minus infinity to r. देखिए infinity से हमें r डिस्टेंस तक मूव कराना है. अगर हमें पॉइंट Q पर निकालना है इलेक्ट्रिक पोटेंशियल, so from infinity to r we have to bring this. So this is limit integral minus infinity to r. What is the value of dW? That is equal to f dx. Negative already I have considered. Now what will be this? So minus infinity to r, substitute the value of force 1 upon 4 pi epsilon naught Q naught upon x square dx. Okay. Now see 1 upon 4 pi epsilon naught Q naught upon Q naught, all these are constant. So that will come out from the integration. So here will be minus Q naught upon 4 pi epsilon naught. That will be out of the integration. Integration will be done of 1 upon x square. 1 upon x square will be x power minus 2. Now you know the formula, x power n integration is x power n plus 1 upon n plus 1. So this will be minus Q naught upon 4 pi epsilon naught x power minus 1 divided by minus 1. X power minus 2 plus 1 upon minus 2 plus 1. Infinity to r. Now just substitute the value, upper limit minus lower limit. So this will be, okay, consider this minus out. जब आप इस माइनस को भी बाहर ले लेंगे, ऑलरेडी एक माइनस बाहर है और ये माइनस भी बाहर आ रहा है, so this will become positive. X power minus 1 is actually 1 upon x. What is the limit? Infinity and r. Now substitute the limits. Q naught upon 4 pi epsilon naught 1 upon r minus 1 upon infinity. 1 upon infinity is 0. So what you will get? Q 1 upon 4 pi epsilon naught Q naught divided by R. So this is the electric potential or the work done. Okay. Now what is the electric potential? We already know V is equal to W upon Q naught. So total work we already have calculated, and upon Q naught is known as electric potential. So 1 upon 4 pi epsilon naught Q naught upon R divided by Q naught. Q naught and Q naught gets cancelled out. So 1 upon 4 pi epsilon naught Q upon R. So this is the value of electric potential due to a point Q. Okay, due to a point charge Q. So this is equal to V is equal to 1 upon 4 pi epsilon naught Q upon R. From here we can conclude that electric potential is inversely proportional to the distance, and this is independent of direction. So इलेक्ट्रिक पोटेंशियल में कोई डिफरेंस नहीं आएगा कि आप एक टेस्ट चार्ज को कहां से लेकर आ रहे हो, किस डायरेक्शन से ला रहे हो, फ्रॉम दिस डायरेक्शन, दिस डायरेक्शन, दिस डायरेक्शन. This only depends on the distance. So we can say that electric potential is symmetrical, okay, for direction. Okay, so you might have understood this. So this was all about electric potential due to a point charge. Notes are already written on this, so you can copy it out. Thank you. God bless you.